Hi, my name is Jubin Soni, and in this episode, I'm going to talk about what the agent tracing in Microsoft Foundry looks like and how the data flows, how to set it up, whether you're running a prompt agent in the portal or instrumenting your own agent code. By end of this video, you will see the difference server side and client side tracing, how to connect the application insights to your Foundry project, what OpenTelemetry span looks like in the real agent run. So let's get into it. So let me start with the problem that tracing solves because it's easy to skip past it. And AI agents are fundamentally different from the regular APIs when it comes to debugging. So when we have a REST endpoint and it returns a wrong value, you have the clear execution path, which is the request in, the logic runs, and there is an output in terms of response. But when an agent doesn't, the AI agent doesn't work that way. A single user message might result in multiple LLM calls, tool invocations, retry loops, and branching decisions made by the model at the runtime. So none of that is visible from the input and output alone. And without tracing, when something goes wrong, you are working backwards from the wrong answer with no visibility into what happened in between. So that's not a debugging workflow, it's more of a guessing. Tracing fixes that, and every time your agent handles a request, Foundry captures the full execution trace, the exact prompt sent to the model, and the model responses, every tool call with its arguments and results, and the latency of every step, the tokens per spam, and whether any retries happened or not. So that information is what lets you answer why did my agent made the wrong tool call, why is the response taking 8 seconds, which step is consuming the most tokens, and how I can answer those questions. uh, and how I can answer those questions, or use those questions to improve my model, or my prompts and the context that it has. So the Foundry builds this on OpenTelemetry, which we'll cover in a moment, and stores it on Azure Monitor Application Insights. So let's see how that actually works. So let's look at this tracing architecture diagram. So this is what I have come up with. The open telemetry layer is here and the storage and the viewing is here. On the left side, the agent runtime inside Foundry. So when an agent runs, whether it's a prompt agent or a hosted agent, there are three types of steps that emit telemetry. The agent service itself, which wraps the full run, each LLM call and each tool call. And each of those steps emit the open telemetry span. A span is just a structured record of unit work, and it has a name, a start time, a duration, and a set of attributes. For the LLM span, those attributes include the model name, token counts, the prompt, if you have been enabled prompt recording, and for the tool spans, that include the tool name, the argument, and the result. So those tool spans are exported via OLTP protocol. So that's what I've mentioned here to Azure Monitor Application Insights. The application insights is the storage and the query layer, uh, and it's where the raw traces data live. From there, two things read that data. The Foundry portal, specifically the operate section, the traces tab, the queries application insights, and render the span tree as a visual in a visual tree view like a GNAT chart, and then the Foundry Trace Inspector VS Code extension, which I have built, also reads from the application insights and shows the same data right inside your editor. We will cover that extension in the episode 4, which makes the life so much easier. You don't have to go to the Foundry portal at all. You can just view all of it in the VS Code. And then the important thing to understand here is that the same data trace is behind both the views. Once you connect the app insights to your Foundry project, you get all of this automatically. So there are two modes of tracing in Foundry. They serve different purposes. One is the server-side tracing, and another one is the client-side tracing. So there are server-side tracing is automatic. Once you connect the app insights resource into your Foundry project, uh, the Foundry starts capturing the traces to your prompt agents and hosted agents without any changes to your code. It covers the full run duration, every LLM call with its input and output, and every tool call with its argument results and token counts and latency across the every span. And the data goes back like up to 90 days, as what I've seen. And if you build a prompt agent, uh, then you already have the server-side tracing in your in every conversation. So let me go back to that slide. And then the client-side tracing requires you to instrument your own code. It applies the like when you're running your hosted agent, so your own Python or C# application. And the idea is that the Foundry can capture what happens inside its runtime boundary, but it can't see your application code is doing outside the boundary. So if you have pre-processing, custom logic, your custom orchestration, then those aren't visible in the server-side tracing. And the client-side tracing lets you emit the OpenTelemetry spans to your own code, and you can export them to other app insights alongside your server-side span. So you can also export the other OLTP compatible backends like Datadog, Grafana, Tempo. Uh, and then the practical starting point is server-side tracing first, which we are going to cover here, and then add client-side instrumentation when you're building your hosted agent and need the visibility in your own application logic. So let me take you to the how to connect the application insights. So I'm in my agents tab, and so you must have seen my previous videos. You go to you create an agent. So I have multiple agents I can show you all the resources. So this is my project, and I can go to build section here, and then I can see all my agents. So I will go to the helpful AI agent because that's where I have most of the data. Then you go to the tools, and then you in the toolboxes preview, you can create a toolbox. I'm not gonna create it, and I can search for the available tool here. So let me see. Yeah, so connect a tool, and then I can search for the tools here. So application. So when you are searching for configured, so these are the tools that you have uh, configured, ready to use with your existing authentication and configuration. But you have to go to catalog, and then you can search for application, see the Azure application insights, and then you can create it. So that's how you connect your application insights. And then there is also multiple Hugging Face, MCP layer, Lovable, Oracle. So all of these tools are available to you that you can select from the catalog. So I have, and you don't necessarily need in the newer Foundry version, you for viewing the um, for viewing the traces, you don't necessarily need to connect the App Insights tool. You can just view the tracing here by going to the traces. So I'm going to expand the start date because I have been playing this for a while. So you can see I have a lot of conversations already. So I will select a conversation from one of the runs that I had. And you can see this is what that tracing looks like. So let's have a new conversation in the playground, and let me show you how that tracing is generated. So I'm going to ask it or just have a conversation with it. Hi, and then it is going to respond. Yeah, I need help in knowing the weather for my city for tomorrow and probably this whole week. So it's going to understand my query, but it doesn't know my city. So I'm going to provide it my zip code. So which is 94102. I'm just going to type any zip code. Is near my home. and then it's automatically detects San Francisco, and then it gives me uh, and then uh, can you tell me the best day this week to go out with family? And it also pulls up the data from this source, which is pretty nice. And then you can see the whole conversation, the time it took. So this was the call or answer which took the most time, which is almost 5 seconds, and it consumed a lot of tokens as well. Versus this was 3 seconds. This took just 301.5 seconds, and we can have access to the YAML call, the metadata, and and we can also call this agent in our Python code. So let's go to the traces view where we can see the entire trace. So this conversation is from today, from right now. Let's see. Let's open this, and I have this metadata. So I'm going to see how this agent was invoked when the user input was hi and the agent responded with hi, how can I assist you today? And then so this is the tree trajectories tree view, and it's shown as a GNAT chart here. Uh, and then this is one. Let me show you how this trace is. So this is one trace where there is one input and one is the output from the agent. So input plus output. So this is one trace, and then this is the response ID. So the response ID is what the agent responded. And then this is another trace. So when I asked this agent about the weather, so user input was, I need your help in knowing the weather for my city. So the agent responded with, so it's giving a JSON response, which the LLM or the agent has given in a manner which the user can read. And then when I look at the third trace, so this was the third trace. And sure, could you tell me the city? So, and then the fourth trace is, again, it's repeating something. And then there was another search. Could you tell me? So these are all conversations from different times, but we had this conversation within last 2 minutes when I was showing you this demo. So this is what the tree view looks like. And if you look at the full conversation, the conversation ID I've copied over here, and I'll show you just right now in the probably the playground. This ID is different than this ID, the conversation that I'm having with the agent. So back to the traces tab and this conversation ID. So you can already see the E is different over here. But yeah, you get an idea. So if you look at, so these are two different conversations and different IDs, and each trace have a different ID. So we look at the full conversation and like we get different traces. And we can also see uh, the user view. So I gave it my zip code, and this was the conversation I was having with the agent, and I can see full replay of my conversation. And I can select a point when this conversation I was having with the agent. And then I can also see the execution of the tool. So over here, the tool was executed and that's what took the most time, which is understanding my query when the agent was invoked, and then the tool was executed. And then if you see when I asked for the best day, and then there was no tool that was invoked. So it's not 100% clear from what's going on in the input plus output, but this is the later part of the conversation when there was no tool invoked because I just asked for a best day and it relied on the previous context to give me the answer. So this is very helpful in when I'm playing in the playground or when I have my own agent, when I'm developing something and I'm having conversation in with the agent. So I can call the agent on in VS Code and have conversation with it and come back over here, look at the details, look at the traces, look at uh, and so I have to set up monitoring in App Insights to have this monitoring enabled. And it also shows some basic monitoring already. And you can look at the agent runs, the time, like when it completed. So it completed 4 agent runs. And over here it tells me the token matrix. So how many tokens it has utilized. So far it has utilized 9,000 tokens and in 4 agent runs, there has been no errors. The tool calls and the agent runs. So so it shows the count of the tool call and the agent runs. So there have been no tool calls. I mean, there has been some. And then this just shows the agent runs when I hover my mouse over here. So that's about it for the tool calling. And then this is what the open telemetry span looks like, which I've already shown you. So on the left, there is a real example when the LLM call span. Uh, so this is for the GPT-4o mini model, but you can select any span name and and then follow these open telemetry GenAI semantic conventions, and then this is also a minimal example of the client-side tracing uh, in Python. So first install the packages. You need the Azure AI project for sure, and Azure Identity for authentication, OpenTelemetry SDK for the OTel runtime, and then Azure Core Tracing as a bridge between the Azure SDK and OTel. And then second, create your AI project client using your project endpoint and default Azure credential. The endpoint format is your Foundry resource name dot services uh, dot azure.com slash API slash project slash your project name. So you can find it in the project overview in the portal. And third, call the configure Azure monitor in your application insights. Fourth, call the um, all instrumenter dot instrument. This is what the auto instruments all the Azure AI project SDA calls. Without this, you have to create spans manually for every LLM call. And then enable the recording flag, which is worth pausing on right now. When it's true, the span include the actual prompt text and response content. So keep this false in production unless you have thought that you need this data for governance later on. Yeah, and then this what we discussed already. So after connecting, like you may see the trace open in the detail view. On the right side, there is a span tree uh, over here, and then you can see and expand it. I'll show it once again. So when you go back to this span view in the conversation, you can click on it. You can see the metadata, which is very helpful for understanding and having some transparency between the content and the type. And then GenAI dot usage, you can get the input tokens, and you can see what conversation we are having, what is the ID, and you can build your own application with this basically. And then coming back to my slides, so you can see the individuals span as we in and as we saw, and yeah. So this slide is a quick reference. These are the key open telemetry GenAI semantic conventions, and most important ones for you is like for debugging are GenAI.usage.input tokens and output tokens for the LLM calls. So those help map the cost of the tokens. And at the agent service span level, thread ID and run ID let you find specific conversions in your traces, useful when a user reports a problem and gives you their session context. So uh, let's recap. The tracing in Foundry is built on OpenTelemetry, and you have two modes: server side, which we saw already, and the client side as well in the previous slide when I showed you the code example. And in the next episode, we'll take one of these traces and look at the VS Code using Foundry Trace Inspector extension that I built. So we'll walk through the authentication setup, loading a specific trace by a response ID, and reading the GNAT timeline, and then what to look at when something goes wrong. So that's it for this video. Thank you for joining me, and see you in the next one.